Hi, everybody. I want to quickly explain to you a very useful rule for taking derivatives called the chain rule. The chain rule is a rule that you use when you have a more complicated function that's actually a function of a function. So it's how you take the derivative of a function of a function. That sounds complicated, but let me show you an example and then we can talk about how it's a function of a function. For example, um, we have a function, let's say f of x is equal to x plus x cubed to the fourth power. So it's not that we couldn't expand that out and get a whole bunch of, terms with just x to some power. It would just be super tedious. Expanding things to the fourth power are annoying. So we just have to go through all of that. And it's not worth going through all of that if you know the chain rule. So the chain rule is where you can notice that x plus x cubed is actually its own function, which I'm going to call u of x. And then you can see how f is really a function of u to the fourth, but then u is a function of x, which is x plus x cubed. Okay, so let's take a look and see how we would calculate with the chain rule df dx. The chain rule tells us, which we're not going to prove, you'll use it a ton of time. It'll start to feel really comfortable, and you will probably prove it when you take calculus, and it is proven in Appendix A7 of Quick Calculus. So df dx, the way you do it is first you differentiate the function with respect to the first level function, df du, and then you multiply by the derivative of the internal function, du dx. So it's kind of like, it's called a chain rule because you're kind of doing a chain style, a level of differentiating. First, you're differentiating with respect to the sort of outer function, and then the outer function with respect to the inner function with respect to x. So let's do that example here. So if we wanted to take df dx, first I would do df du. So I would do d by du of u to the fourth, right? Where u is x plus x cubed. And then I would multiply that by du dx, knowing that u is this function. So the cool part about this is that d by du of u to the fourth, well, we know that from the power rule is just 4u cubed. And then du dx is just the derivative of this polynomial over here. So d by dx of x is just the number 1, and d by dx of x cubed is 3x squared. And so now I can just go back and I can actually plug in for what u was. So df dx equals 4 times x plus x cubed. That's my u, and it's cubed because it's 4u cubed times 1 plus 3x squared. And that's the derivative of df dx. Much simpler. Let's do one more quick example with a slightly kookier exponent, just so you could see why these things start to be somewhat useful. Let's go to a new page. One more example. D by dx, let's say we have the function f equals 1 plus x to the 1/2, or the square root of 1 plus x. Now, this is like a super annoying function, right? Because you have this square root and you don't really know what to do with this half power. We can still use the power rule and the chain rule, and this becomes a much simpler way to do this, to differentiate this. So here we would notice that this f is really a function of u, where u is 1 plus x, and then f is just u to the 1/2 power. You get good at noticing what that u function is over time. Sometimes it's pretty obvious, other times you've got to kind of be a little more clever about it, but it's one of the things you do a ton of in calculus. So let's say df dx is going to be df du, that's a d, times du dx, and df du is u to the 1/2, right? So df dx is equal to d by dx, sorry, not d by dx, it's equal to d by du of f, which is u to the 1/2, times du dx, again knowing u is 1 plus x. The du dx is actually a pretty easy one to do because it's just 1 plus x. So du dx is equal to the number 1 because the derivative of 1 is 0 and the derivative of x is 1. So we can keep that in mind. That was a more straightforward one. So df dx. Let's do the power rule. We haven't done it on a fractional exponent, but it's exactly the same as a regular exponent. So you pull the exponent, hops down in front, and then you minus 1 from the exponent. So it's 1/2 u, and now 1/2 minus 1 is u to the negative 1/2. And then du dx, the derivative of this function is just 1. And so this is going to be 1/2 times 1 plus x to the negative 1/2 power. That's it. That's how you do chain rule. Again, it's really useful for functions like this, and pretty useful for functions like the one on the previous page. Give the last problem a shot. If you're stuck, we're definitely talking about this on Friday, so no worries. Have a great rest of your week.